All right, let's take a look at section 5.6, inverse of a function. We start off, what is an inverse? The simple way is functions graph that reflect at y is equal to x. Hopefully since Algebra 1, you've learned that, an inverse is simply if you were given a table of values, you go ahead and you switch x and y, and that would be the inverse. But when it comes to graphing, it's this reflection of y is equal to x. And let's take a look right here. If we were to graph, kind of show you the simple function, if we have our xy axis right there, and then y is equal to x, would simply be this line, right? You have the origin right there at 0, 0, and then the slope is up 1 to the right 1, or slope is 1. So there you have, it's reflecting across that line right there. And there you have y is equal to x. Put right here, functions that interchange the input and output values of the original function, or simply domain and range are interchanged. And that is what I just pretty much explained just a little while ago. And I believe that's probably what many of you are more aware of as far as inverses of functions. But you've heard inverse also when it comes to exponents and exponentials. You may have heard the term used there as well. Simply put, if we take a look next at this core concept, the inverse of a function f is also a function if and only if no horizontal lines intersect the graph of f more than once. So if you look at this first function right here, this is pretty similar to, let's just say, like x to the third type function. And so the question is, at any point, if you draw a horizontal line, does it cross the function more than once? Okay. If it only crosses the function once, then that means it passes the horizontal line test. All right. And that means that that inverse has a function. But if you take a look right here at this next one, we have a parabola, right? And it does not pass the horizontal line test, because right there you can see that that horizontal line in red crosses the function more than once. Therefore, it's not a function. So one of the main things right here that you're going to have to do mathematically to determine if you have a function or not, because you're not always going to be able to graph, is you can determine if an inverse is a function by plugging g of x into f of x. And if it simplifies to x, the equations are inverses of each other. You may see right here this kind of as like your proof. Easier said than done, right? It sounds like it's pretty easy, or it sounds difficult, but it's not as bad as what you may think. So let's go ahead and try this out. First off, it says let's solve for f of x for x, then find the input when the output is -6. So on problem number 1, okay, they're saying find the inputs. But if you look at the equation, remember this f of x typically is just y. So what you're going to have to do here is, well, how do I find the inputs when the inputs are x? Let's take this equation and we're going to go ahead and solve for x instead. So if I have y is equal to 2x minus 1, let's go ahead, we'll add 1 to both sides. So I now have y plus 1 is equal to 2x. And then let's divide both sides by 2. And so x is equal to y plus 1 divided by 2. So we found, we have it solved for x. That'll allow us to find the inputs. And then they're saying, well, the output is -6. This is pretty bizarre because a lot of times it's the opposite, right? We are finding what y is, which is the output, and they tell us what x is instead. So now for the final step right here, you're going to go ahead and plug in -6 into the equation. So we have -6 plus 1 divided by 2, and that equals x. We got -6 plus 1 is -5. So x right here happens to equal -5/2. All right. Let's go ahead and repeat this process. Let's try number 2 right here. So we'll start off. We have this as y is equal to 1 minus -x squared, but we want to solve for x. So let's subtract 1 to both sides once again. So I have y minus 1 is equal to -x squared. Let's go ahead and divide both sides by -1. Okay, so we want to get rid of the negative. So now I have x squared is equal to y minus 1. Actually, we can go ahead and simplify this, and instead of putting it over -1, how about we just divide each term by -1? So now we have -y plus 1. And so for us to now get rid of the exponent, we can go ahead and square root both sides. Don't forget, when you do square root both sides, you do need to put plus or minus right here. So let's put our simplified part, our equation, as plus or minus the square root of -y plus 1. And that is equal to x. So last but not least, they're telling us that the output is -6. So let's see what happens. We plug -6 in for y, and things work out somewhat nicely, because at first you might be concerned that, hey, we're going to have a negative in the radicand, but we actually are not. So we'll go ahead. -6 ends up being 6. 6 plus 1 is 7. So this right here, it doesn't simplify to a nice answer, but it is plus or minus rad 7, and that is okay. All right, so the job once again, switch x or solve for x. The equation is already solved for y, and then from there you're going to go ahead and plug in the output so you can find what x is. All right, so now let's take a look next up at number 4. We have now, it says find the inverse of the function, then graph the function and its inverse. How do I find the inverse of the function? I put right there in red. You're going to switch x and y and solve for y. Okay, so remember, our equation right here is f of x, or which is the same thing as y, is equal to 10x. So step 1, let me go ahead, we'll move this over right here. I will take my equation and write this as x is equal to 10 times y. So I switch the variables, and then we're going to go ahead and solve for y, and I'll divide both sides by 10 right here. And so y is equal to x over 10. Let's go ahead and graph our functions. Okay, so the first function right here is y is equal to 10x. Remember, we always want to start off, figure out, well, what is our y-intercept? There is no y-intercept, it's technically plus 0. So we'll start at the origin. And then remember, 10 right here represents the slope, rise over run. So what I will do, remember the slope right here, m is equal to 10. Let's go ahead and do intervals of 5 right here for the sake of space. And I need to go 2, 4, 6, 8, 10 all the way up here, and then to the right 1. Let's do intervals of 2 for y, and we can do intervals of, actually we'll do intervals of 2 also for x. So there's our first point, there is the second point. You should always try to have 3 points. It helps you make a straight line. Although 2 points make a straight line, but there's always room for error when it comes to what we're doing right here, especially when you don't have a ruler. All right, so let's go ahead after that. I've got my points, and let me go ahead. Let's draw ourselves a line right here that goes through that. And there's our parent function, or not the parent function, but the original function. Y is equal to 10x. All right, so next we're going to take this right here and graph that as well. Now you're saying x over 10. Remember, that is the same thing as 1 over 10x. So we could actually say that my slope right here is 1 over 10. We start off, when we graph this, we have our y-intercept. So our y-intercept on this as well is at 0, 0. And then our slope is up 1 to the right 1. So if I go up 1 unit and then all the way to the right 10 units, there you have it again. There is our function. Okay, let's go ahead and draw ourselves a line that goes through that. And there you go. There's your function. And there's the graph. So we now have the parent function. We also have the inverse. Now remember, they are inverses because they do they reflect across a particular line. That line is right here. I'll use this fancy pen. And this is y is equal to x. And that is what it's reflecting across. And so we've graphed both our function and parent function right there. Okay. So step 1, switch x and y. Solve for y again. And then go ahead and graph both functions after that. Let's take a look at number 5 right here. So step 1, let's go ahead. I'll take the function. I'll switch x and y. I've got, so this will be x, and I'll put this, let's put it over here to the side right. We got x is equal to negative 1/5 y minus 7. So let's get x by itself. We'll go through the steps. Let's add 7 to both sides. So now I have x plus 7 is equal to negative 1/5 y. And then in order for us to get rid of the negative 1/5, how about we go ahead and multiply both sides by negative 5, the reciprocal. The reason why I said negative 5 instead of positive 5, so I don't want that negative over here on the right hand side. I want y to be positive. So that'll make this y, and y is equal to, and then we can go ahead and distribute the negative 5, negative 5x minus 35. So this will be an interesting line to graph, but that right there is your inverse. Okay. I guess for good practice right here, we can go ahead and draw out our function, our axis. All right, so let's take our parent function right here, or the original function. Looks like we're going to have to probably go intervals of 10 to make things work out a little bit better here. So yeah, let's do intervals of 10. So down here we have our y-intercept of -7, and then we'll go down 1 to the right 5. And so it'll be something like maybe right there. Down 1, and then down 1 to the right 5. And then we'll be right here. So it's not really moving a whole lot. And let's just kind of there's our parent function, or the original. The inverse function right here, we have to go all the way down to -35. And so -35, let's go down. So we're 10, 20, 30. -35 will be right there. And then it says we are going to go down 5 and then to the right 1. Down 5 to the right 1. Okay, so this line happens to be doing something like this. So having done this by hand, I've noticed that, hey, my graph doesn't look very good. I think probably a lot of it's because of the spacing and the intervals that I have here. So let's check this out. Went ahead right here and graphed this using Desmos, and it looks a whole lot better. You can see that right here, this is where they intersect, not way up by the x-axis. And then you're saying, well, how? Because if you looked at the original one that I drew by hand, it didn't look like it reflected across y is equal to x. But this one right here definitely looks like it. We're to draw a line that goes diagonally right here. You can see exactly it goes through this point of intersection, and it is an inverse. Unfortunately, it didn't come out that way right here, as you can tell. All right, so we have done with that. Let's take a look. Up next, determine whether each pair of functions f and g are inverses. So what do? Pretty simple. Remember, if we have our functions here that are inverses, that means that x and y would be switched. All right, if you switch, you just got to be able to switch x and y. So let's take a look at, first off, here's x. We got 4, -3, -2, -1, 0, and 1. And if I look right here, I've got down for g, I got -4, -3, -2, -1, 0, and right here, take a look at that. Are those two exactly the same? They should be, because remember, with inverses, the x and y values are switched. There's nothing about the x and y values switching signs. It's just that they're switching spots. So right here, I would say, I think they made a mistake. This probably should be +1. So let's just say, for the sake of our problem, because this one's actually supposed to be yes. So I think they had a typo right here. And let's just say that this right here is +1. Because everything else looks the same, right? If we look now at these values, x, that's now y, 17, 13, 9, 5, 1, -3. So let's just go ahead and say that this was a typo. and then they are both positive 1. So right here, determine if the function are inverses. We'll say yes. The reason why, once again, your x and y coordinates are switched. If you take a look at number 8 right here, let's look at the values of x. 1, 2, 3, 4, 5, 6. I've got 1, 2, 3, 4, 5, 6. So that x looks good, right? The x and y, they have switched. But take a look right here. These numbers do not look the same, right? So simply put, no. The x and y coordinates are not switched. The x became y, but they're completely different numbers. So right there, they're just two completely different graphs. They are not inverses of one another. Let's go down next up to number 11. It says use the graph to determine whether the inverse of f is a function. Explain your reasoning. This is where we have that one simple test that we went over. The horizontal line tests. If at any point in time it does not pass the horizontal line test, then that will be determined that the inverse is not a function. So right here, number 11, no. Reason does not pass horizontal line test. I'll just abbreviate that with HLT. If we take a look at number 12, same deal. Look, it passes right there, great. But it doesn't pass right here. So once again, this is no. It has to pass all the time, not just one time, 2 times, or wherever. All the time. Okay. Lastly, let's take a look right here at number 13. We want to determine whether the functions are inverses of each other. Actually, let's take a look at number 14. So on these problems right here, remember we said if you take g of x and you plug it into f of x and it equals x, and you take f and plug it into g of x and it equals x, that means they're inverses. So let's put it all together right here. To start off, it's saying, let's take what we have right here and plug that into g of x. So we have 2 plus, and we have 6 minus, and we're going to plug in f of x, which happens to be negative. And then we have x minus 2 to the 5th power. We'll close that off. And then we have what's remaining, which is to the 1/5 power. So let's go ahead. We got to simplify things out right here. And I've got 2 plus. And then we have 6 plus. And it's going to be x minus 2 to the 5th raised to the 1/5 power. Actually, let's go back a step. Looks like there's one thing I forgot right here. And I forgot to include the plus 6. And then we go ahead and have this raised to the 1/5 power. Remember, those signs, they do get in the way. They can be very, very annoying, right? So if we're subtracting, let's go ahead. We're going to add the opposite right here. right? And because this negative already initially exists within the problem, right? The 6 minus, we're going to have to go ahead and let's change the signs. And then this will become now a minus 6. So if we put it all together, I've got 2 plus, and then we have the 6's end up canceling out because it's 6, or this ends up being plus, and then we have right there negative 6. So I'm left with now x plus 2 to the 5th power, and then all of this is raised to the 1/5. And so when we raise a power to a power right here, and then I don't know why that right there, let's fix that, because that should be minus 2. So what you're going to see here now is I have 2 plus. When I raise a power to a power, I multiply. And then so what I'm left with now is just x minus 2. Because 5 times 1/5 ends up equaling 1. So we go ahead, 2 plus negative 2. And guess what? We're left with just x by itself. When I took f of x, I plugged it into g of x, it ended up equaling x. It's amazing, right? That means we have inverse. If I take g of x right here, and I input this into f of x, you also have to check that and make sure that you get yourself, you get x as well, which you do. So right here, I've got negative, and then I'll just go ahead and just start the problem, set things up. Over to the 1/5 power right there. And then we have minus 2. Whoops, let me go ahead and erase this, because minus 2 is part of that original equation. And then we raise this to the 5th power, plus 6. So after all is said and done right here, when you simplify this out, you'll end up with x as well. And then you'll be able to get, you'll realize that they are inverses, right? What happens here, look, the 2's will cancel. Right, when we raise a power to a power, once again, you'll see that this right here will equal 1. So now I have negative 6 minus x plus 6. I'll go ahead and distribute the negative right there. And so I have negative 6 plus x plus 6. And guess what? It ends up equaling x. Inverse. So those two equations are inverses. You can see how I plug one equation into the other and then simplified it down to see if it equals x. And that right there is the end of chapter 5 for us.